Here's a really interesting GMAT quant question, which involves some inequalities, and I know this can be quite a tricky topic. So if you'd like to see anything similar to this on the channel, or if you have any suggestions for any specific problems that you'd like to see, let me know in the comments. So let's read this and let's see how we should approach it. So we know that x is positive, so let's write that down like this. X is greater than 0. And the question is, which of the following three options could be the correct ordering of 1 over x, 2x, as well as x squared? Okay, so the first option has x squared as the lowest number and 1 over x as the highest number. Then we have x squared as the lowest number, 2x as the highest number, and then 2x the lowest and 1 over x the highest. And we're going to check which of those, if any, make sense. Okay, so let's start with the first one. Let's see, what should x be for this inequality to make any sense at all? Okay, so to do this, we're gonna split the inequality. So first of all, I'm gonna look at whether this can happen, or I'm gonna look at when this can happen. Then I'm gonna look at when this can happen, and then we're gonna put everything together. We're gonna do an intersection of sets, basically. So let's take the first one, which is x squared less than 2x. So can this actually ever happen? And to figure this out, I'm going to rewrite it like this. So I'm going to move everything to one side, which gives me x squared minus 2x less than 0. Okay? Now, we can factorize an x, which will give us x multiplied by x minus 2 is less than 0. So at this point, you could technically use a sign diagram to do this. And let's actually do that. So this is what we're trying to do. We're trying to find what is x such that this is true. And to do a sign diagram, this is how it looks like. So first we write x, and then we write x minus 2, and then we write x multiplied by x minus 2. Now we have 0 and we have infinity here. Now x doesn't actually take the value of 0, but we're still gonna write it here. And then here we have a 2, and obviously x is positive everywhere. Now x minus 2, on the other hand, this is negative until 2 when it's 0, and after that it's positive. And then when you multiply x with x minus 2, you will get, well, technically you get 0 here, but this value is not, x doesn't take a value of 0. So this is negative, this is 0, and then this is positive. Right, so that means for this to be negative, we have to look at what should x be so that this takes values in this range. So, and we can see that that range corresponds to 0 to 2. So in other words, if x is between 0 and 2, then this inequality holds. So in other words, you can take any number you want, whether it's an integer, which is just 1, or whether it's a rational number or an irrational number. As long as it's between 0 and 2, it will satisfy this inequality always. Okay? So this first part is satisfied when x is anywhere in this range. So let's now look at this other part. So this is 2x less than 1 over x. And let's see if this can actually be true. So to do this, we're gonna put things on one side, just like that. And what I'll do now is I will bring this to the same denominator. So that's gonna be 2x squared minus 1 over x is less than 0. Okay, so we're now trying to figure out when this can actually happen. So let's write maybe the numerator. Let's try to force factorize it too, just to make things a bit easier. So we have this over x less than 0. So let's do a sign diagram again. We have x, we have x squared minus 1 over 2. And then we have, well, then we have the whole fraction, which is 2 times x squared minus 1 over 2 divided by x. And we know that x goes from 0 to infinity. It doesn't actually take the value of 0, but we already know that. Now, the first question is, when is this going to cancel out? And you can actually check for yourself, but it will cancel out when x is square root of 2 over 2. This has a second root as well, which is negative, but we know x doesn't take any negative value, so we'll ignore that. Now, if you do this for values from 0 to root 2 over 2, you'll see that this is going to be negative. This is going to be 0, and it's going to be positive from this point onwards. Obviously, x is positive always. So when you divide one by the other, you're going to get negative here. This is going to be 0, and this is going to be positive. So our inequality looks like this. So the x values which satisfy this inequality are going to be in this range. Okay, so as long as x is greater than 0 and less than square root of 2 over 2, this is satisfied. Okay? Right, so now let's go and put everything together. So the first thing was asking whether x squared can be less than 2x and whether it can be less than 1 over x. So let's write it like that. So this part is true if, and then we have x between 0 and 2, so we showed that. This is true if x is between 0 and root 2 over 2. So here's what we have. Here's a more visual way of seeing this. If 0 is here, this is root 2 over 2, which is a bit below 1, and this is 2. So this range satisfies the first inequality. This range satisfies the second inequality, and the question is, where do both of them overlap? And the obvious answer is, of course, here. So this is the part that's in common, which means that if x is between 0 and root 2 over 2, then this whole double inequality holds. In other words, this can, let's use a different color actually, this can be true, right? As long as x is between 0 and root 2 over 2. Now, let's look at the second one. But before we look at the second one, there's one more thing I would like to do at this point. Although we proved that this inequality can hold, and we treated those two things separately, I would also want to look at the first and the last parts of the inequality. In other words, I want to check when can x squared be less than 1 over x. Right? So we looked at x squared being less than 2x, which we did here. We looked at 2x being less than 1 over x, which we did here, and we got this result. But now I also want to look at when can x squared be less than 1 over x. So let's try that. So we have x squared less than 1 over x, and this gives x squared minus 1 over x less than 0. We're gonna bring everything to the same denominator, so we have x cubed minus 1 over x is less than 0. So we can factorize this like a polynomial, so we can rewrite the numerator as x minus 1 times x squared plus x plus 1 over x less than 0. And if you're not sure about it, this is actually equal to this, and you can convince yourself, right? If you multiply, if you expand those brackets, you will get x cubed minus 1. Right, so we can use a sign diagram again, but I'm gonna skip that point. The idea is that this is always going to be positive. Let's use blue maybe. So this is always going to be positive. So the only thing that that could make this fraction negative is this x minus 1. Okay, and you can use a sign diagram again just to make things a bit more rigorous. But the idea is that if this is negative, then the whole inequality is going to be negative. And this is negative if x is between 0 and 1, like this. So this inequality will be true if x is anything between 0 and 1. So if you pick any number from there, x squared, the value that you picked, will be less than 1 over x. So that's what we have. And let's actually write everything together in a nice way. So x squared less than 2x is true if x is between 0 and 2. Then we have 2x less than 1 over x, and this is true if x is between 0 and root 2 over 2. And then we have the last one, which is x squared less than 1 over x, and this is true if x is between 0 and 1. Right. Now, we already showed the first statement to be correct. Now, let's look at the second one. So the second statement says that x squared less than 1 over x and less than, of course, 2x. Right? So all statements have x, either x squared, 2x, and 1 over x. Those are the terms we're trying to order. So let's see when each of those are true. Now, if we look at the first part, x squared less than 1 over x. So we know that x squared can be less than 1 over x for x between 0 and 1. So let's write it here. This is true for x between 0 and 1. And we also know that this is true for, let's see, so we're looking at 1 over x and 2x. So 1 over x is actually greater than 2x if x is in this interval. So let's write that down here. So we know 1 over x is greater than 2x if x is between 0 and root 2 over 2. But this inequality has the opposite sign, okay? So if 1 over x is greater than 2x for x in this range, it means 1 over x is less than 2x for x outside of that range. So x is outside of that range, meaning that x is going to go from root 2 over 2 all the way to infinity. Okay? So it's sort of a negation that takes place. Okay, so just to recap, we showed this earlier. We showed that if x is in this interval, 1 over x is greater than 2x. But if 1 over x is less than 2x, then x is everything outside of that interval, which is essentially everything above root 2 over 2. Okay, so now we have to check when or where the intersection of those intervals happen. So we have 0 from 0 to 1, which is the first inequality, and then we have another one from root 2 over 2 to infinity, which is basically this. So there is an intersection, and the intersection happens here. So in other words, if x is between root 2 over 2 and 1, then those two things happen in the same time, which means this inequality will be true. Okay, and that's how you deal with the second statement. So the first statement can be true. The second statement can also be true. Now let's look at the third statement. So the third statement says that 2x is less than x squared and is less than 1 over x, like this. So again, let's take it step by step. Let's look at 2x less than x squared. Can this actually be true? For what values of x is this true? So what we're looking at is here. So we look at 2x and x squared. So we know from this here that 2x is greater than x squared if, let's see what we have, if x is between 0 and 2. Okay, but this inequality says that I want to know if 2x is less than x squared. So if 2x is greater than x squared for this, then it's less than x squared for x outside of that range. In other words, in this case, x is going to be everything from 2 to infinity. Okay? And then we're going to look at this inequality, which is based on this. So we know x squared, so this is, I'm going to rewrite this now. X squared is less than 1 over x if x is between 0 and 1. So this inequality is exactly that. So x squared is less than 1 over x. In other words, for this second half to happen, we must have the x between 0 and 1, just like that. So now let's look at the intersection of the two intervals, but you might already know what's going on. So we have 0, we have 1, we have 2. So the first half must have x bigger than 2. So it's x can be anywhere underneath this this region, and the second half must have x underneath this region. And as you can see, there's no overlap. Okay, so there is no x which is both here and here in the same time. Okay, that's impossible, which means this inequality cannot happen ever. So for any x positive, this inequality does not hold. In other words, number 3 is false. Okay, so we have 1 and 2 which are correct. We have 3 being false. So the answer obviously is D. And that's the end of the question.